questions. Again, those questions are questions just like a test question, so pay careful attention. Let me just go through those. Okay. So the first question is, what is the current that flows? Well, if this is the voltage, if 3.38316 volts is the voltage, right? Then the current, I believe, the current is going to be I squared, or I'm sorry, V over R, right? I got sort of ahead of myself, right? I'm just using Ohm's law here. So it's going to be 3.38316 volts divided by, what does it say, 2.3 ohms, right? So divided by 2.3, and I get 1.47094 amps, okay? Then if you look at the small questions, right, what is the power dissipated? Well, how do we want to find the power? Yeah, we can do IV. Well, I'm going to do, for the sake of laziness, I squared R. And that's because I've got this on my calculator and I know it's right and not rounded. And I know R is 2.3, right? So you can use anything you want. I'm going to use I squared R, right? So it's 1.47094 amps squared times 2.3. Right? So square that number times 2.3. And I get 4.976. Watt is the unit? Okay. What is the total electric energy generated? So now we found power, right? This is how many joules per second. How do we go from joules per second to joules? Multiply by time. Okay. Are there questions on 30 or 31? I'm hoping not. Are we good? I don't know. I'm just going to write it here. Okay. So now we're figuring out the total energy. Power is, well, power is work divided by time. So work is power times time. Yes. Does that make sense? Yeah. Okay. So work is power times time, right? Which is 4.976 joules per second times 0.621 seconds, and that's 3.09 joules, right? Then it says if the magnet moved 3.75 centimeters, sorry, to affect this change, EFFECT, that means to cause, not to influence, okay? If it did that, what is the force acting on it, right? So how do you relate, guys, can I interrupt? I know this is exciting, but try to just stem the side conversations there. Okay, so how do you relate? It's asking us to relate the energy and the distance and the force. What's that relationship? Panic is not that. What is the relationship between energy, force, and distance? Work is force times distance. I love this, right? Okay, so this is 3.09 joules, right? Okay, force times 0.0375, right? They tell us 3.75 centimeters, right? So divide this by 0.0, and that's where you get the 82.4 newtons. That's kind of a cool thing, huh? So that much force for that much distance makes that much work. It tells you that. It says if you had to move at 0.0375, doesn't it say that? Oh yeah. Oh yes. It's in the little afterthought there. The skill sets don't ask that many questions. I think they might ask the voltage and current or something like that. Okay, and so, or maybe they ask you for the resistance. Oh my gosh, right? Okay, so but I just put those on there because it's just like the test question, and here's a good example to get you ready for that.